Next, we have to study refining of metals. See, we have studied different methods of obtaining the metals. These different methods were like roasting, calcination, then reduction to metal by reacting the oxide of metal with pure carbon, that is coke. When we obtain the metals by reducing process, the metals obtained will be containing impurities in them. They will not be very pure. So in order to obtain pure metal from the impure one, a process is employed. It is actually something like filtering process. And this process of obtaining pure metal from impure one is called as refining process. It is called as refining process. In this process also, electricity is used. The electricity is used. So now we have to write the definition of refining, and then we'll see how refining is done. The metals extracted by various reduction processes are not pure, are not pure. They contain they contain so these impurities must be removed, right, to have the pure metal. These impurities must be removed in order to have pure metal. The process of removing impurities is called refining. Is called refining. If electricity is used for refining, for refining, then the process, wrote it two times, should write here, then, right? Then the process is called electrolytic refining. Is called electrolytic refining. The metals that are refined electrolytically are copper, zinc, nickel, silver, gold, etc. So now what we have to do is we have to learn what is electrolytic refining. Okay. See, in this process, the impure metal is made as anode and a thin strip of pure metal is made the cathode. I will explain it very clearly. A solution of the metal salt is used as an electrolyte, is used as an electrolyte. In case of extraction of metals by using electrolysis, we have used the molten ore. We have used there the molten ore, but here we are making use of the metal salt solution as an electrolyte. In the sense, if I have to refine copper, then I will have to use copper sulfate as an electrolyte. Which metal I have to refine? That metal salt solution I have to use. And a cathode should also be a thin strip of the metal which is to be refined. That means if I am refining copper, then the cathode should be made up of pure copper and the anode should be of impure copper. Impure copper means copper extracted from the reducing process, which we have studied previously. From copper sulfide we obtained copper oxide, and copper oxide is further heated, which gives us copper and sulfur dioxide. But the copper obtained here is not very pure. It will be having some impurities in it. So you can call it as impure copper. Now this impure copper is to be made as an anode in the refining process. That I will show in figure. So it is refining tank here. So this is refining tank. Okay. And say here we are having anode, and then this side we are having cathode. This is tank for refining process, and let us say we are having here one DC supply source. You can take it as battery also, plus minus this side, and let us say we are having a switch here to switch on and switch off the source. And call it as key also. Key or switch, both mean same. So this is anode because it is connected to positive terminal of the battery, and here we are having cathode. Current flows in this direction. It starts from positive terminal of battery. Correct. Electrons will flow in the opposite direction. Electrons will flow in the opposite direction to current. And say here it is acidified copper sulfate solution. Why it should be acidified? If you acidify, copper sulfate will start to carry current easily. acidified CuSO4, acidified CuSO4 solution. Okay. So anode is what now? It is impure copper. Impure copper. Cathode is what? It is made up of pure copper. Very thin strip you will have. Very thin strip you will have. See, when the current is passed, from the anode, copper ions will be released into the electrolytic solution. That means here you will have Cu plus 2 and Cu plus 2. Where these are added? These are added to the copper sulfate solution in the tank. And when these are added here, from the solution, from this solution, equal amount of copper ions will reach the cathode, Cu plus 2, and from somewhere here, I can show it like this, Cu plus 2, and enlarge it slightly, Cu plus 2, will reach the cathode. When they reach the cathode, they will take electron from the cathode because cathode is negatively charged. So one copper ion will take 2 electrons and then it will become Cu, that is copper atom, pure copper atom, and it will get deposited on the cathode here like this. So this will also take 2 electrons from the cathode, become copper atom, and then it will get deposited on the cathode. So like this, in the impure anode, as many as copper atoms are there, they will be removed one by one, and they will be added to the solution, that is electrolytic solution. And from the solution, Cu plus 2 will go to the cathode. So when all the atoms are removed, whatever the impurity, sand, it may be some ash there, or it may be some soil there, that will all get collected just below the anode. So this is impurity here. This is also called as anode mud. It is also called as anode mud, MUD, mud. Remember, for this the key should be closed, then only it will happen, because current has to flow. So what is happening here? See, you are having impure copper. When you pass the current, in the tank, then the impure copper here will become ion by losing electrons. That means they will become Cu plus 2 like this. Where it goes, Cu plus 2 goes into Cu plus 2 goes into electrolytic solution. Cu plus 2 will go into electrolytic solution. But what is electrolytic solution? Electrolytic solution is nothing but CuSO4 acidified. That means few drops of acid you will have added. When you pass the current, it will dissociate into Cu plus 2 and SO4 minus 2. Is it right? SO4 minus 2. That means in the tank now you are having Cu plus 2 from electrolytic solution and Cu plus 2 from anode. Now Cu plus 2 will be attracted by cathode because cathode is negatively charged, Cu plus 2 is positively charged. So when the Cu plus 2 comes towards cathode, it will become Cu. Now this goes where now? This goes to cathode. At cathode what happens? At cathode, this Cu plus 2 will gain 2 electrons and it will become Cu. Now it is solid and pure metal. Okay. So for all these reactions, we'll give the explanation now. The apparatus used for refining of copper is shown in figure above. On passing the current, through the electrolyte, the pure metal from the anode dissolves into the electrolyte. An equivalent amount of pure metal from the electrolyte is deposited on the so you have to understand here what is the meaning of an equivalent amount of pure metal that I have shown actually in the figure here. What explanation is given here that matches with the figure you see here. Two ions from anode are removed and two ions from electrolytic solution are taken by cathode. That is called as equivalent amount. If from anode you take three ions, then from electrolytic solution you will take 3 ions on the cathode. This soluble means impurities which can dissolve in solution. The soluble impurities go into the solution. That means they dissolve in electrolyte. Color of the electrolyte should change, is it right? Whereas the insoluble impurities settle down. We have shown it in the tank. At the bottom of the anode and are known as what they are known as. We have written in the figure anode, mud, anode,